Hi guys, in this lecture we'll be discussing about a sample problem on a continuity equation. As we know, the continuity equation has been derived from law of conservation of masses. So whatever the mass that enters into the volume controlled volume will be equal to the mass that exceeds the controlled volume. So we know that the formula to find the discharge through the pump, which is equal to area into velocity for incompressible fluid. So let's take a problem. Water flows through a pipe AB. So we have the different sets of pipes. So pipe AB of 1.2 meter in diameter at 3 meter per second. So the water that flows into the pipe AB equal to 3 meter per second. So the diameter of pipe is given as 1.2 meter, and then passes through the pipe BC. From AB it passes through BC. Is 1.5 meter in diameter. So diameter of pipe is 1.5 meter. At C, the pipe branches. Branch CD is 0.8 meter in diameter. So this pipe diameter is 0.8 meter, and carries 1/3 of flow in AB. So whatever the liquid that flows into the pipe AB will be 1/3 of fluid that flows in CD. The CD will carry 1/3 of fluid that flows in AB. Okay, for example, if 75 liters per second of fluid is been flowing through AB, so 25 liters will be flowing through CD, and remaining 2/3 of that is 50 liters per second will be flowing through CE. So carries 1/3 of flow in AB. The flow velocity in branch CE is 2.5 meter per second. So it is given that in CE the fluid flows at a velocity of 2.5 meter per second. Find the flow volume rate of a flow in AB. So volume rate, flow rate, mass flow rate. So everything denotes the discharge, which is equal to Q. So we're going to find the volume flow rate in section AB. Velocity in CD. So the water that flows in pipe CD, we're going to find the velocity, and diameter of the pipe CE. So what will be the diameter of the pipe CE? So here diameter of pipe AB is given as 1.2. Velocity of flow through AB is 3 meter per second. Diameter of pipe BC is 1.5 meter. Diameter of branched pipe CD is 0.8 meter. Velocity of flow in pipe CE is 2.5 meter per second. So we're going to assume that the flow rate in pipe AB equal to Q meter cube per second. So as we know that, so in terms of meter cube per second, so 1 meter cube will be equal to 1000 liters. So 1 meter cube of volume of container can hold up to 1000 liters of water. Okay, so assume that Q equal, the flow rate in pipe AB equal to Q meter cube per second. So velocity of flow in pipe BC will be equal to VBC meter per second, and velocity of flow in pipe CD equal to VDCD meter per second. So this has few few parameters, so that we're going to consider, rotation that we're going to use to find the velocities and flow rates. Right. First, what we're going to do is, so now volume flow rate through AB. First one we're going to find volume flow rate through AB. So Q will be equal to, as we know that, volume velocity into discharge. So discharge will be equal to velocity into area. So velocity, as we know that, it is given 3 meter per second, and area will be pi by 4 d square, so which is a area of a circle. So 3 into pi by 4, diameter is already given 1.2 meters. So if you calculate that, it will be 3.393 meter cube per second. So always keep in mind that if the diameter is given in mm, convert it to meter, right? So if the units of velocity is given in terms of centimeter second or mm per second, okay, so whatever it might be, try to convert it into a single standard meters. Okay, so even if it's given in meter per minute also, you have to convert it to second, then you have to substitute, right? So be careful in converting it to the standard terms. So the value will be 3.39 meter cube per second. So applying the continuity equation, we know that the mass of fluid enters into AB will be equal to mass of fluid enters in BC. So discharge in AB will be equal to discharge in BC. So velocity into area in pipe AB will be equal to velocity into area of pipe BC. Velocity of pipe AB, we know 3 meter per second. Diameter of pipe AB, area of pipe AB 5 by 4 d square, which is equal to velocity of BC into 5 by 4 dBc square. So diameter of pipe BC. So from this we have already know the value, which is equal to 3.39 meter per second, 39 meter cube per second, which is equal to VBC into 1.5 the whole square. So simplifying this, we will get 1.92 meter per second, which is the velocity of fluid that flows in this pipe BC. So next we're going to find the flow rate through pipe CD. So CD will be, as we know that it takes 1/3 of fluid from the total discharge, this AB. So whatever the fluid that flows in AB, whatever the fluid that flows in CD will be equal to 1/3 of fluid that flows in AB. So through AB we have found the discharge is 3.39 meter cube per second. So by 3, so we will get 1.131 meter cube per second. This amount of fluid that flows in pipe CD. So in this pipe we will get only 1.131 meter cube per second. So Q will be equal to velocity in pipe CD into area of pipe CD. So Q1, which is equal to 1.131 meter cube, will be equal to velocity of pipe CD into area of pipe CD, which is 5 by 4 d square. So diameter of pipe CD, we know that 0.8 meter. So if you simplify it, so you'll be able to find the velocity through pipe CD, so which is 2.5 meter per second. So now we need to find the flow rate through CE. So what will be the fluid that flows in CE? So as we know that whatever the fluid that enters into the pipe should have to leave CD or CE. So as we already we know that the CED carries 1/3 of fluid that goes, it has been flowing in AB. So if 1/3 is flown through CD, so probably 2/3 will be flown through CE. Alright. So Q2 will be equal to Q, which is a fluid flowing in pipe AB, minus Q1, which is a fluid flowing through pipe CD. So if you subtract, you can get 2.262 meter cube per second, or if you put 1 by 3.39 by 2, you will be getting the same. So 2 by 3, 3.393, sorry. You will get the 2.262 meter cube per second. So then Q2 will be equal to, so discharge will be equal to velocity into area of the pipe. So if you put them in, you can able to find Q2, we know the value which we have found. Velocity of CE is given 2.5 meter per second. So flow velocity in band CE 2.5 meter per second. So if you substitute, then you can able to find the diameter of pipes CE, which is equal to 1.0735 meter. So this is a basic problem which defines the law of conservation of masses. Hope you guys would have understood. Thank you for watching.